this computer. Okay, so what we're going to talk about today is a few requirements. Hathaway and Corey, if you remember last year, there was and in all other, well, at least in the bioscience program, there is what is called basically like a bioscience contract, an engineering contract. And it has with it the program description and requirements. And so like what's being expected of you guys. And so I just want to make sure that like everything is crystal clear. It's laid out on the table. We all know kind of where we're going, what's ahead of us. Okay. And so the tricky thing about this is that I was looking at that program description, and I really didn't want to like hack it all up, and because things are just going to be so different with this whole COVID situation and partially online and schedules being all goofy. So hey Jason. So I really didn't want to like hack into this document because this is not the normal, right? This is definitely an exception. So there's not really going to be like any signing of any document, because again, like I don't want to modify that document to try to translate what this year is going to be like. And honestly, like I can't even project everything anyways, because I don't know. So what we're going to do is we're just going to kind of go through some of the heavy hitting objects, some things that we just need to either be informed of or make ourselves aware of. There's going to be one little change that I'll talk about that will, Corey and Hathaway, that'll be a little bit different this year, but I did tell you about it last year. So we'll talk a little bit about that. And so what I'm going to do quick is just share my screen, and then we can look at, let's see here. So, last year I gave you guys a terms and conditions sheet, and had your parents sign it, and then you returned it to me. Well, some students returned it to me. But the whole idea is that, we kind of lay everything out on the table, and, just make sure that everybody knows we're all on the same page, that, participation in the engineering program requires additional coursework and time commitments that are in addition to all of your other SSM academic requirements. And really it's all about, having the end goal and end result of being able to graduate with honors in engineering. And so that's what we're all shooting for. And if you're in the program, that's like the plan. And so before there were like kind of some gray area options about not doing that, and that's really not an option anymore. Okay. So then it says, I have read and understand and agree to all the engineering program description requirements, blah, 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 blah. So what we're going to do now is take a look at some of the program descriptions and requirements. And so this is a little bit heavier, and again, a lot of this stuff is just like doesn't apply to what we're doing, the way that we're doing school right now. So what I want to do is kind of just hit on a few of these things that I feel are applicable and are worth mentioning and talking. So first of all, we're kind of an engineering lab. So looking at some of the program objectives, I've talked about some of the objectives in class that apply to class, but I want to talk a little bit about the objectives for lab. And so number 2, I came up with these objectives that I felt are very important, kind of, the foundation of the program. Number 2 says, give students an opportunity to design and build a machine or a device that performs a task or demonstrates an academic concept. And this design project is intended for students to pursue their own engineering interests. And I kind of already been talking about that a lot, to select something that you're really passionate about, things that you love, because then it's just going to be an absolute joy to spend some time with your project and make some progress. And so this also, building a device or a machine, it doesn't necessarily apply. It doesn't sound like it. Maybe I should reword it, but there's a whole digital side of that, of the design. So like the programming end of things and app development and software development and that kind of thing, that fits into number 2 as well. So that's kind of the objective of lab. That's what we're shooting for. And so another thing that I want to lay out on the table and make sure that, you know, everybody understands is that being a part of the program automatically requires you to do a project. Okay. And we're going to talk about the different types of projects today, build projects versus design projects and what they mean. And so being a part of the engineering COE means that you're going to be working on projects, because that is what engineers are doing constantly. Every branch of engineering, they're all about working on different projects and solving problems. And so that's a big part of this, the whole experience. Okay. And so what's going to be a little bit different this year than versus last year is that the engineering project or engineering lab, like for you guys would be 8th period, is now going to be a graded component. Okay. So it'll be, you know, a B, C, D, F scale. It's not going to be a pass fail. And honestly, the way that we're going to set this up is that, you know, you'll be graded based on, you know, you're not going to get like, you know, a bunch of assignments and tests and things like that. This is totally different, right? It's not like a traditional class. The way that you're going to be graded is based on your project entirely. And so, you know, it'll be based on the check-ins that we do. And so, you know, whether or not you're making progress with the goals that we set, you know, you're not sloughing off, and, you know, not doing any of the work that we kind of schedule and, you know, try to keep it so that your project is moving from start to finish. And then it'll also be based on the presentational aspect of your project. And so we're going to talk about what that's going to look like this year, potentially. And so those couple things, again, I almost think of it as like, you know, it sounds bad, but it's like, you know, this is the project, you know, the assessment part of it thing is more like, this is the hoops that you have to go through. And, you know, let's just jump through the hoops and it's an easy A. Okay. That's almost the way that I think about it. You know, I really don't like the way that that's worded, because really to me, more of this, the lab side of this program is all about the experience. And so, you know, when you start adding grades to stuff, sometimes it can detract. I don't know if that's a word. I think it's a word, but I just made it a word. If it's not, it can like take away from that experiential component. And so I don't want it to do that. I want the grades to be real simple and straightforward. But it helps us get so that people don't bail out of their projects and be like, well, can I just not do a project? Well, it's like, no, because doing projects is like all about, you know, being an engineer. Okay. So that's something that we've changed this year. So all students are going to meet regularly through check-ins. That's somewhere buried in this. It's there. But so we'll meet regularly with check-ins. And again, what I'm shooting for is, you know, since our numbers are a little bit lower than what we started with last year, I'm thinking that we can shoot for 1 meeting per week. And again, these don't have to be like long drawn out check-ins. You know, they can be relatively quick, and, you know, what you're working on, and, you know, where are you at, show me your progress, then what can we do next, that kind of thing, get you to the next step. And then let's talk a little bit about that presentational aspect. So what I'm envisioning right now, normally we would do like some sort of a fall, like very, very like end of fall semester, or like early on in winter semester, term, whatever, trimester. We would do a poster presentation. Okay. And the tone of that poster presentation is all about like, this is my project. I want to introduce it to you. I want you to get involved in, thinking about this idea. If it's a design project, which for all of you guys, you should be thinking about design projects. It's all about, oh, here's Tina. It's all about thinking about, here's the problem that needs to be solved. Here are some of the constraints that I've identified in the project. And here's my solution to the problem. This is what I'm going to be working on. Now, at the point of the first poster presentation, I would not expect anybody to really be at the point of having a final completed project, unless it was like a real basic build project or a real basic design project. Most all of you are still going to be working at that. And so it's the end of the year poster session where it's like, here's my finished project, right? This is what I was working on all year. You know, we started out with these problems that we needed to solve. We identified these constraints. I made a prototype. Here's the prototype. This is how the prototype works. You know, there's a little bit of a bug here. So some future work that we could do is maybe change out this module to something else, which would solve my problem. And so that's kind of the tone change that's different, right? You're looking at the front half of the project during the first presentation, and then you're looking at the total end of the project and the way that it came full circle. So does that make a little bit of sense? Okay. So there's a couple, so for 9th through 11th graders, you'll be doing poster sessions. But if you're a senior, again, to be able to graduate with honors in engineering at the end of the year and have that on your diploma, which again is part of the plan of the program, you will do the poster session in the fall, but you will do a formal presentation, likely via Zoom, and you'll create a presentation, and we're going to work really close together to really dial that presentation in, make sure that it's rock solid, and you get like a whole bunch of praise from all the faculty at SSM when we're done with it, because that's really how it was last year. It went over very well. So more of a formal presentation than an informal poster presentation where you're just, you know, talking to people and then they go on and talk to somebody else and that, so on and so forth. So that's kind of like what projects look like, you know, this year. So there still is going to be some sort of a presentational aspect. If we're not presenting posters like in the hub or something like that, which I almost doubt that we will, it would be some sort of a virtual poster session. And so we need to talk about, I got to talk with Maren in the bioscience program and figure out the way that we can kind of unify that procedure and what's going to work for everybody, because we kind of want to be all the academic COEs doing kind of the same thing. So that's a little bit about kind of expectations. So now what I want to do is I want to talk a little bit about the projects and kind of the objectives and the goals of the projects. And this is something that I didn't really do last year. And I kind of kicked myself for it. You know, there was a lot of figuring things out last year, and this was just one of those things that I wish I would have done. Do you guys probably still see Microsoft Word? Give me a sec. Share screen, PowerPoint, okay. Slideshow from the beginning. Okay. So projects overview. So this is actually a really difficult presentation to give, and it's a very difficult presentation to even make, because the range of projects that you can get involved in the engineering COE is just, it's endless. Like you could get involved in all sorts of different things that I'm not even familiar with, you know, just all sorts of different things. And so you could be doing things from like, you know, build projects with basic robots and putting together different parts. You could even couple that with trying to 3D print and do like a kind of like a pseudo design project and build project where you're 3D printing some aspect of this robot that you want to create, and then, you know, figuring out how these different motors and these different circuit boards are going to all attach to it. And so it can totally be, you know, a complicated robotics project, you know, versus you could take more of the digital approach. Okay, we've had students who have developed apps, done some programming, done some games design. There are elements of the engineering design process right there. And so that's totally acceptable too. So that project looks different than a robotics type project versus an electronics, type component project. Like all of these things look different. And so for me to kind of pitch this to you and give you all these ideas, it's really hard because there's like 50,000 different projects that you could get involved in, and the sky's the limit. And so what I want to do is I recognize that complication, and what I try to do is try to kind of streamline and get there to be certain types of projects. And so what we call those projects are build projects and design projects, right? And so what I did is I put together a little flow chart, as general recommendations. I think this is a kind of be helpful for some people, maybe not all. And this is another complication of projects. We have 3 terms, right? In a year, you could technically do 3 different projects. Okay, we kind of break it up by term. Like this term I'm working on this project, this term I'm working on that project, and so on and so forth. So you could get involved in 3 different projects. If they're design projects, I doubt you'd be able to get through them all. Okay, and so if you're taking on a design project that's even remotely complex, that's probably going to eat up your whole year. Okay, and there's a lot that goes into that. And really it depends on where you want to cut ties with it and say like, okay, I'm completed with my project. I'm happy with the outcome. We found something good. We designed something, we created something, and I'm ready to move on to something different. And so to just say like a build project takes 2 semesters or 3 trimesters or whatnot, you just can't do it. It all depends on the project. All right. So like if you're a first or second year in the program, you got a few options depending on, grade level and all that. Like ninth grade, first year in the program, I'd recommend doing some build projects for a little while to kind of get your feet wet a little bit and get, comfortable with some tools and build some skills and all of that. But I've had 9th graders last year who came in and had some real good ideas to do some design projects. And, we kind of ran into a little bit of, some problems and headaches with that. So, if you want to do design projects, if you get your mind set on something, you really want to do it, I'm not going to, say, no, don't do that. I'll work with you, but we should think about build, smaller design projects, and you got to be really passionate about what you're working with. You can also do that pseudo type project where you're kind of intermingling build projects and design projects. Okay, you can have like a build project, but kind of take that and say, well, you know what, I've completed this build project, but I want to take this and I want to change it in some way to be able to do this, whatever that may be. So you can take and, tweak your projects to say like, this is, you can add that design element into a build project. Okay. First year program, if you're in 11th or 12th grade, I would probably recommend starting out with a fairly good build project, like a complex build project for the fall term, and then transition yourself into winter and spring term design project. Okay. And so start to think about like, I'll get this build project and kind of, get my feet wet a little bit. And then since you're in 11th and 12th grade, I think you're at the level where you're ready to kind of dive in and start, thinking about design and solving some problems that you want to solve. If you're second, third, or fourth year in the program and you're 11th or 12th graders, I want you to do design projects. Okay, I want you to be taking on design projects. Or even if you're really interested in doing build projects, figure out how you can adapt them and make them into design projects. If you're a 12th grader, you have no choice whatsoever. It's design projects. So, so again, the whole objective of our program is really to get you to realize, think about, apply, and recognize the beauty of design. And that is the heart of engineering right there. And so I really want you focusing on those design projects. So let's talk a little bit about the overview of build projects. We're going to do the overview of build projects, kind of the objectives that we're looking for in a build project, and then we'll do the same thing with design projects and what we're looking for. Okay, so A build project is really a kit type project where someone else, likely an engineer, has done the design work for you. Okay, they've designed, for example, this watch to be able to function and work, and they design it to be a kit so that each of the components can be assembled by somebody else, not a manufacturing plant. Okay, so this was one example that I found. I almost feel like this is going to be too simple. Rotate is a company which was a Kickstarter business. I think a couple years back. You know, they had this idea of making watch kits, and you know, because tinkerers love to build things, right? So there's a market there of building these kits. You know, people have this strong bond and this appreciation for being able to say like, hey, I'm wearing this watch and guess what, I built it. So they kind of, you know, I think this is like one of the first real kit type products for watches. And so I almost think that this would be too simple. You know, yes, it looks complex, especially looking at the way that this piece of machinery is used, but we want to avoid getting kits that are, you know, you get them one night, you're really fired up about it, you're like, oh, I want to build this kit, and you're done with it the next day. Okay, those are, you know, we want to avoid that kind of thing. I've had students do drone kits, and you really got to be careful with drones because there are a lot of drones that are already like mainly assembled, and like you just like have to attach a few components. That's not the kind of kit that we're talking about. Okay, the kind of kit that we're talking about has got like a bunch of pieces, and it's going to take a good amount of time to get going and put it together. All right, so I've kind of highlighted on some of the objectives of build projects, but let's just recap. Okay, so all projects that you're going to do for your engineering have to be approved by, you know, myself or whoever else is working in looking at projects, which last year was Mr. Ray, but I'm not sure if he's going to be a part of that. But they will be pitched, they will be approved, whether or not this is going to be a good project for you to use as your engineering project. All right, so what are we looking for? These are constraints. It must be complex in nature. Okay, so we're not looking at like, you know, 10 parts that's going to take you 10 minutes to put together. No, that's not what we're looking for at all. Okay, so it's got to be complex. It's got to consist of a lot of parts that are assembled, that are put together, that take some time to assemble. All right, we're not looking for overnight projects. We're not looking for even week-long projects. We want projects that you actually have to learn skills in order to build the kit. Okay, so skills like, well, maybe welding, who knows? I mean, that would be a kind of a big kit, but welding would be a good example. Soldering, I think, would be a more common example. You know, like robotics types kit, you'd have to learn the skill of soldering. If you were to do another robotics type program or a kit, learning how to program the whole robot to do things that you want to do. That's also another skill that you would learn in the process. And so we want you to be able to build skills and resources that you can put in your toolbox, so that when you want to use, when you want to do different projects, you can fall back and be like, oh yeah, I used this tool, you know, a while back. I'll have to brush up on it a little bit, but it's not going to be as bad as starting from scratch. And so, you know, build projects where maybe you use like a CNC or a laser engraver or something like that. You know, being able to learn those skills along the way is like, that's what we're after. Okay. And also I added this in here because when you get to actually presenting this build project, it's really good to start off by saying, the reason that I really chose this build project is because I had this problem and I wanted to build this thing that would solve this problem. And so it's a really great opportunity to get the conversation flowing. And, you know, it's all poster sessions start with some sort of an introduction, a purpose, that kind of thing. Okay, so I want you to think about, you know, your project being not just some random thing that like has no meaning or connection to you, that you just want to build it just to build it. I want you to pick a project that has some meaning to you. Okay. All right, so let me just look at your faces again. because I have to close you guys out in order for me to see the presentations. Does anybody have any questions on like build projects or anything like that? Any thoughts? I mean, please feel free to talk. I'm tired of talking already. Okay, well, you just have to hear me talk for just a few more minutes, and we're going to talk quick about design projects. And honestly, these are a little bit even more challenging to talk about. So I'm going to close your faces now again. Let's talk about design projects. I stole a few of the design projects, things that I'm going to talk about from projects that were going on last year by our seniors. And so design projects are totally different animal. And so they're selected by you to ultimately solve some sort of a problem. And so by solving some sort of a problem, oftentimes, like almost all the time, you're going to have to learn like a ton of new skills to try to figure out how to solve your problem, or be able to figure out how to adapt the skills that you know to be able to solve the problem that on hand. Okay, so I stole a couple examples of some students' projects last year. One of them, Neo, he was working on kind of like what we would call like a mechanical type project. And so, and that's going to differ from the other one that I'm going to talk about real quick. So Neo is really super into, you know, old vintage cameras and videos and, you know, making videos and all that. And so this is what's called a Super 8 camera. He got a hold of one. And these were used back in the, you know, the 60s and the 1970s to actually make movies. And so these didn't capture audio. But what they did is they had a trigger on there, a trigger mechanism. You would hold it up and you would look at the through the eyepiece there, and you would push the trigger, and then you would be taking basically video footage of whatever you were pointing your camera at. And so it had a film cartridge that was in there. And so when you press the button, it turned on a motor which advanced film in front of the whole lens piece, which exposed it to the light and you know, made the video image on there, or made a series of images on there. And when you know, have the motor take the film across it, you create a movie. And so he was really into this idea. He loved you know, the look and the feel of these old cameras. But the problem is that even getting a hold of good film cartridges was a little challenging, and he was even more challenging to get them developed. And so you know, obviously, let's try to come up with some sort of a solution to get around that problem. So what he thought about was digitizing this Super 8 camera. But he made the constraint, and this was a tough one. You know, this constraint really made this project very challenging. He wanted the look, the feel, everything to be the same as a normal Super 8 camera would be. And so he wanted the fact that like when you press the trigger, you start taking video, and you know, he wanted the look. He didn't want to modify the camera at all. No holes, no nothing, plug and go. Okay, so what that meant is that he needed to design a cartridge that would go in there. And so he designed this cartridge on a 3D modeling program, 3D printed it. And you know, after he thought about what components need to go in this cartridge, you know, we sized it and made sure that it would work. And so then he started thinking about making some sort of a crude prototype using a breadboard, just to make sure that you know, all the components are doing what it needed to be doing. And so unfortunately, the project, fantastic idea. Love the project. You know, where he was going with it, it kind of got cut short with all this COVID BS. So what he did get to is kind of making this initial prototype, and it kind of worked. I mean, we were able to capture video, but it wasn't at the frames per second that we really wanted. And so, you know, it kind of worked, but that's more of a mechanical type project where you're assembling parts and pieces, and you know, you're 3D printing stuff, maybe you're laser engraving things, you're CNCing things, you're milling things, or you know, doing things like that. You're creating things for some sort of product or something physical that you can hold in your hand. Elena Gross was another senior last year, and she kind of took a different approach to design projects. And she was really into computer programming. She was planning on being like a software engineer or something of the sort. So she really wanted to design an app to solve a problem that she had with the busing system. And so, she was tired of waiting for the bus outside, especially in the winter. She was tired of doing that. So, what she did was design, she worked on designing a bus app that would track the bus, and so that all students could see where it was at, and then they could figure out when they would need to go out to the bus. And there was also a component of being able to communicate with the driver and kind of give them updates of like, okay, there's 5-6 people here waiting for you, or whatnot. So she went through and used various different app building coding softwares like Unity and Xcode, and kind of utilize these things called CocoaPods, which helped her kind of develop the app. And unfortunately, again, with the situation, we didn't make nearly as much progress as we wanted, but the idea and the design project was there. And those are the kind of different projects that we would consider design projects. All right, so let's look a little bit about what we're looking for. So in order for it to be a design project to be approved by the engineering world, it all starts with the problem that you're trying to solve, right? This is not just some, I'm going to design this for whatever reason. Like, I want you to be thinking about making this really real and like trying to solve some sort of a problem. And, even like that popcorn machine, even though as cheesy as it was, it still solved a problem, right? And it was all based on the fact that, people want to be lazy. And so, who knows? Maybe you have somebody who doesn't have any arms and they need something to feed them. And so you never know. So all engineering projects start with a problem that you're passionate about and that you really dive into and try to solve. Now, here's the tricky bit. We've had design projects, even in my 1 year being here previously last year, and I've heard many stories about projects in the past. There have been design projects that were started but never got finished. And because they didn't really think about all of the constraints ahead, and they didn't really think about how complex their project actually was. And so we need to understand our limitations. I'm not saying that, your brain is limited and you can't, do these things. You can do whatever you set your mind to. But, if you come to the idea, pitch and be like, okay, I have this problem. I can't get to class. I want to do it in style from the dorm. And so I want to build this battery operated car. I really want it to look like a Tesla. And, I'm going to look at you and be like, okay, that's a great idea. Believe me. And I highly encourage you to pursue that. But we need to think about what's realistic and what's not. And so I really don't want you guys to get started on projects and not be able to finish them. And so big part of my job in the whole collaboration part of things is to kind of think about that whole aspect on what's possible and what's not. And so, again, it's a conversation. I'm not just going to say like, okay, we're never going to be able to do that. We could take that and adapt it and, massage it and figure out something that would be something that we can do within a year. Okay. Or something like that. So it's just something to think about. For design projects, like I told you before, the projects that go wrong are the ones, and the projects that don't get finished are the ones where the people didn't really fully think about the complexities of their project and the constraints of their projects. And so this is the vision. At the very beginning, you have to have the vision of what your project is going to look like. And believe me, that is the most difficult part. You're going to be doing some sort of modeling with this project, or prototyping or something like that. So oftentimes this is going to be done with some software. So some CAD modeling software, or depends on the project. If it's electronic, you'll be getting breadboards out and connecting a bunch of wires or stuff like that. So there'll be some sort of a modeling aspect to your project. And then ultimately the biggest objective is that your design project is going to apply the engineering design process. And so you're going to go through, define the purpose, define the reason that we're doing it, define the constraints, have your your idea or your design to be able to solve those constraints and problems, and then come up with some sort of a prototype, test your prototype, figure out if it works, reiterate your design, and then keep looping right there, the reiteration point. And so we're going to talk a little bit more about that design cycle a lot more, but the design projects really have to hit hard on that. And so that's what I've got. I just wanted to give you kind of a brief-ish overview of projects. And I know it's kind of probably a system overload right now. But what we're going to do tomorrow during this lab time is we're going to talk a little bit about project pitches. Okay. And so I don't think it's going to take us nearly as long as it did today to talk about that. So we'll talk a little bit about a pitch. I'm not going to do a pitch for you. I'm just going to talk about what it is so you can start thinking about it. And then we'll be free for the rest of the week to kind of start thinking about projects and what are some things that you want to do. And so I'll have a little bit of a structured resource that you can use to kind of flesh out some of those details. So what kind of thoughts do you guys have? Anything, questions, concerns? Okay. Even if you're not necessarily comfortable asking the question in front of a group, please reach out to me on email. We can set up an individual Zoom meeting. I can get back to you on email, whatever you're comfortable with. And, I just want to make sure that, you're not wandering around in the dark and not really understanding what's going on. Because then that's when, your experience level goes down and it's not as fun. So make sure you reach out when you need. Advocate. Okay, so for topics of ME people, I will see